Hey, welcome to the Explainer. Today we're going to crack open a real GCSE computer science exam question. We're going to break down a programming puzzle step by step and show you how to turn it into a perfect score.
So how do you actually tell a computer how to store data and then find it again? It's a huge question in programming, and we're going to tackle it by looking at a problem straight from a recent OCR exam paper.
All right, so the whole setup for this question is a school sports day. We're being asked to help build a program to keep track of all the data for students and their teams.
And honestly, this is a classic problem you'll bump into all the time in programming. It's all about how you organize your information so you can get it back when you need it, quickly and efficiently.
Okay, so let's get into it. First things first, we've got part one of the question. We need to pick the perfect data type for 3 different bits of information the program's got to handle.
So here's the table, pulled right from the exam paper. You can see we've got 3 variables, an example of what they might look like, and then that empty column we have to fill in with the right data type.
Now, before we jump in and fill that out, what is a data type, really? Think of it like a label that tells the computer what kind of information it's looking at. And getting this right is so important, not just for the exam, but for any program you'll ever write. Seriously, picking the wrong one can waste memory or even cause massive errors, whether you're building a banking app or the next big video game.
Okay, first up, team name. The example is super team. So what are we looking at here? Well, it's text, right? A bunch of letters and a hyphen. That means we need a data type that's built to handle a string of characters.
And yep, if we check the official mark scheme, the answer is string. Simple as that. A string is your go-to for any kind of text. Okay, 1 down, 2 to go.
Next, we have student year group. The example is 11. The key thing to notice here is it's just a whole number. No decimals, no fractions, just a straightforward number.
And that right there is the perfect job for an integer. Integers are made for whole numbers, whether they're positive or negative.
All right, last one, javelin throw. And the example is 18.2. See that decimal point? That's the big clue. This is definitely not a whole number, so an integer is just not going to cut it here. So the mark scheme says the right answer is either a real or a float. Both of these are designed specifically for numbers with decimal points. And choosing correctly here is super important for getting things precise, whether it's for scientific data, money, or, even a javelin throw. Awesome, that's part 1 done and dusted. Okay, let's keep the momentum going and jump into the second part of this challenge. Now, things get a little more interesting. We have to complete an algorithm to actually find a student in their team. So here's the deal. We have a list of student names stored in something called an array, which is really just a fancy word for a list. Our job is to fill in the blanks in a linear search function. And all a linear search does is look through that list, one item at a time, until it finds what it's looking for. Nice and simple. And this is the exact code snippet they give you in the exam. You can see it's a function, it has a loop inside, and there are 4 big gaps that we need to fill in to make it all work. All right, you ready? Let's solve this thing. We're going to fill in these blanks using the exact wording from the official OCR mark scheme, so you know this is the good stuff.
First up, blank number 1. This goes at the end of our for loop. The answer is the team.length -1. And what that does is tell the loop exactly how many times to run. Remember, computers start counting from 0. So the very last item in an array is always at the position length -1. Super important detail.
Okay, blank number 2. This goes inside our if condition. We put count in the square brackets. This lets us use the count variable to check each student's name in the list, one by one, as the loop runs. Blank number 3 is what we're checking against. The answer is student name. So the whole line now asks, is the current team member's name the same as the student name we're looking for? See how that works? We're comparing the name from the list to the name that was passed into our function. And last but not least, blank 4. If we get a match, what happens? We return true. This is huge. It stops the function right in its tracks and sends back the signal, yup, we found them. And there it is, the finished working algorithm. It goes through every name, from the very first one. If it finds a match, boom, it returns true and it's done. But if it gets all the way to the end of the list without finding the name, then and only then does it return false. It's a perfect piece of logic. See, when you break it down step by step, that question wasn't so scary after all. So what are the big ideas we should take away from all this?
First, always match your data type to what you're actually storing. It saves you from so many headaches. Second, never forget that computers start counting from 0. That whole length minus 1 thing is going to come up again and again. Third, really get your head around the simple step-by-step logic of a linear search. It's a fundamental building block. And finally, understand that return is how a function gives you its final answer. If you can nail these concepts, you'll be feeling way more confident.
And that brings us to one last thing to chew on. A linear search is fine for a small team, sure, but what if the team had 1 million students? What would you do then? Thinking about that kind of scale, well, that's your next step. That's what opens up the door to way more powerful and efficient ways of searching for data.